Hi there, let's take a look at the practice test for Chapter 5.1 and 5.2. Let's take a look at our first question. If my cosecant is equal to -5, I know the cosecant is the reciprocal of the sine, so my sine would be -1/5. If my cosine is positive and my sine is negative, we are talking about, remember, all students take calculus, so the cosine is positive in the fourth quadrant and the sine is negative. So I'm going to be drawing my picture. My theta, or my x in this case, is right there in the corner. My opposite is -1. My hypotenuse is 5. Let's use the Pythagorean theorem to get my adjacent side. -1 squared plus b squared equals 5 squared. 1 plus b squared equals 25. B squared is 24. B must be the square root of 24, or 2 root 6. So I'm going to put 2 root 6 in there for that side. Now we have to answer some questions here. Let's take a look. Our sine, we already said the sine was -1/5, and the sine is the opposite over the hypotenuse, so that worked out well. The secant is 1 over the cosine, so if I take 1 over and then I find the cosine as the adjacent over the hypotenuse, and I do the reciprocal of that, I get 5 over 2 root 6. If I rationalize my denominator, I get 5 root 6 over 12. My tangent is the opposite over the adjacent. Rationalizing again, I get negative square root 6 over 12. Now my cotan is just going to be the reciprocal of this side, so I'm going to call that, start with that, 2 root 6 over -1, or just -2 root 6. Let's move on to number 2. In this one, we're going to use our identity. The cosecant squared of x is equal to 1 plus the cotangent squared. Where the cosecant is, I'm going to put 1 plus the cotangent. So I'm going to have 1 plus the cotangent squared x minus 1 over the cosine squared x. And that's going to be equal to the cosecant squared when we get there. The plus 1 and the minus 1, they go away. And I'm going to rewrite my cotangent as the cosine squared over the sine squared, and then 1 over the cosine for the denominator. If you notice that we have a cosine on the top, a cosine on the bottom, that's going to go away. And I'm left with 1 over the sine squared. We know that 1 over the sine is the same as the cosecant. And so we have verified the identity. Let's look at number 3. Notice that we have a thing to the 4th power minus a thing to the 4th power. That's a difference of squares pattern, so I'm going to factor it into the cosine squared x plus the sine squared x times the cosine squared x minus the sine squared x. And that's equal to our right side. And if you remember your identities correctly, we know that the sine squared x plus the cosine squared x is equal to 1. And so this is the commutative property of that. So I'm going to substitute 1 in for that. And now I have my left side and my right side the same. So we're done. For number 4, we're going to have the cosine x, cotan x plus the sine x is equal to the cosecant x. Again, we're going to mess with the left side of this to make it look like the right. First thing I want to do is I want to rewrite this as the cosine x times the cosine x over the sine x, replacing the cotan with what cotan is equal to. And because this has a denominator of sine, I want to get this one with a denominator of sine so that we can write it as a common denominator. So I'm going to multiply it by sine over the sine. And now I have a common denominator of sine. In my numerator, I have cosine times cosine is the cosine squared, and sine times sine is the sine squared. And same as above, where we have the identity sine squared x plus cosine squared x is equal to 1, I have that right here. Using the commutative property, I can just put the sine first, the cosine second. I'm going to substitute in, and that's 1 over the sine. And we know from our identities that the cosecant is the same as the 1 over the sine. All right, enjoy. Backside's on the next video.